to show you on how to use the Excel program that I created about the singly reinforced concrete beam. A singly reinforced concrete beam. So there are two types: the WSD or the working stress design method, and the USD or the ultimate strength design method. So first is the WSD. So this is the Excel. All you need to do is input the data, the given data, the said problem. And so this is the sample problem. It has a reinforced concrete rectangular beam of 280 mm in width, has an effective depth of 520 mm. It is reinforced only at the bottom width from 5 to 28 mm bar. The reinforcing steel strength, or the Fs, is equal to 140 megapascal, and compressive strength of concrete is 28 megapascal. So use alternative working stress design method, or the WSD, and modular ratio is equal to 9. Determine the moment capacity of the beam and describe the beam section. So WSD method is a method used for the reinforced concrete design, where concrete is assumed as plastic, steel, and concrete act together elastically, where the relationship between loads and stresses is linear. So it means that the working stress design method is designed for RC sections, assuming them to be within their elastic limits. This is where stresses are proportional to strains. Large margins or factors of safety are assured, or material strengths to ensure such behavior. So let's input this given data to the Excel program that in order to solve the moment capacity. Insert picture, insert the beam width of 280, then effective depth 520, then number of bars is from 5 to 28, so let's assume 5. The bar diameter is, let's give it a try of 20. Then the FC prime is equal to 28. The Fs is 140 MPa, modular ratio of 9. What if D is not given? So let's assume that there are instances, so let's assume it's 600. Concrete cover of 40, let's assume 40. So the effective depth difference is simply deduct 600 minus 40, so it will be 560. And constant modulus of elasticity of a concrete is 200,000 MPa, steel rather. Then modulus elasticity of concrete is 4,700 times square root of FC prime, or equals to 24,870. Then the modular ratio, this is on how to get the modular ratio. E of steel over E of concrete is equal to 8.0418, or let's say 8 if N is not given, but in our problem it is already given and it's 9. So this is the, you can solve it in three methods. First is the transfer method. It has an area of steel of 1570.796 mm squared, and it has a moment of area on about neutral axis. It has a value of C of 178.7227 mm. Then the moment of inertia at neutral axis is 2179372950 mm raised to 4. Then in terms of concrete, it has a moment capacity of 153.65 kilonewton meter, and in terms of steel, it has a 99.337 kilonewton meter. Then in order to be safe, let's cut it. In order to be safe, the moment capacity of the beam is 99.337 kilonewton meter. In terms of moment, it must be the lowest among the two. Then, using the resisting internal couple moment method, we have a value of 232.7072 mm. Then it has a, in terms of concrete, it has a moment of 181.62 kilonewton meter. In terms of steel, it has a moment of 97.296 kilonewton meter. Then the WSD constant method. First is locate the constants, so the value of K using the formula of FC over FC plus Fs over N, so we can get the value 0.447514. Then the value of J is 0.850829. Then in terms of concrete, using the formula, moment is equal to 1/2 times 0.45 FC prime times K times J BD squared. It has a moment of 181.6159 kilonewton meter. In terms of steel, using the formula of Fs times area of steel times J times the D, so M is equal to 97.29565 kilonewton meter. That's all for WSD method. So let's proceed to USD method. So as you can see, it has already a data for a beam width of 330 mm, effective depth or tension is 500 mm. Beam properties, it has FC prime is equal to 28, then Fy is 415 MPa. It has a reinforcement values. The number of main bars is 4 pieces. Then main bar diameter is 20 mm. So first is how to get the balanced steel ratios. So using the formula 0.85 FC prime over Fy times beta times multiplied by 600 plus 600 plus 600 over 600 plus Fy, so we can get 0.0288. The given steel area, so if we need to calculate the area of steel using the formula pi over 4 dB squared, we will get 1256.6 based on the given data that I have shown earlier. Then conditions, so if use steel does not yield, so if we use steel does not yield, just focus on this area. It has a value of C is equal to 187.78. If steel does not yield, so let's assume that summation of forces along X is equal to 0, so tension is equal to Cc. Then if you need to calculate the depth of compression block using the formula beta times C, since you already have the value of C, then beta, if not given, it is always 0.85, so you have just simply multiply. The result is 159.61. So the maximum moment capacity is equal to 473.54, and that's all.